have to improve the MPSGE documentation.
Mm-hmm.
And I think a good thing to do for that is to have a discussion of how MPSGE works.
Yeah.
Because it's a black box. May's here. Hi, May. But I'm not exactly. So, like I said, I'm coming from Tom and Ed, and I guess Jim, Mark Hughes, a little bit. And they all kind of think the same way. And I don't know if that's how the general modeling community tends to think about this sort of thing.
Not really. I mean, and that's and I was actually thinking I'd be happy to work with you on this, Mitch, because I've had to come through to MPSGE a little differently, and I discovered at some point the issues I was having understanding MPSGE is that it's built on the dual formulation of the economy-wide problem, which is, it's straightforward once you understand what that is. But I think most people, and there's not that many people trained in the U.S. in CGE modeling anymore, but the people who would be exposed to that are going to come through it from the primal side, and so it might be useful starting from like sort of what would be a standard approach, like the Robinson Lofgren, and then say, okay, well, if you just use compensated demand instead of Marshallian demand, and you take the use Shepard's lemma in order to get I think you can go from a standard problem, even in algebraic form, to its dual formulation in algebraic form, and say, okay, this is where MPSG starts with the specification of the technologies in terms of unit cost function and the consumer problem in terms of Hicksian demand. Because I think otherwise it's probably obvious to Tom and others how that works, but it was not obvious to me until I kind of had to really, because anyone who's going to be exposed to it is going to come from a different side.
It's very interesting because I'm looking at it almost purely from the dual side. I think economics doesn't make a lot of sense to me. Sorry to the audience. Because I mean, one big reason here, let me share just so I can draw a picture. One big reason is that when you draw supply and demand, let me actually make it so that is a little bit more viewable. When you draw supply and demand, you put quantity here and price here, right?
Mm-hmm.
So quantity is like your independent and price is your dependent.
Yes. Well, it's flipped. They call it the inverse demand curve, but yeah, that's the way it's normally presented, and it may go back to Marshall or whoever. I forget the history of that. Yeah.
I don't see why it's not. I understand why you call it the inverse demand curve, because price should be the independent variable. But I think a lot of economists, I think this is wrong. Because you don't control the amount of quantity, you control the amount of price. Like if you're a producer, you're controlling the price.
Well, I mean, depending on whether you could be a price taker, in which case, given the prevailing price, you choose the quantity at which you want to produce at. Yeah. Which is why maybe the bottom diagram, that would be more representative in terms of I'm being driven by price, unless you're, if you're talking about a large.
Yeah, it just seems like everybody says, well, the price is too high, so I'll buy less. Yeah, it's a conceptual thing. That's not part of this, though. But I think in a very real way, it's kind of the same problem, right? Like these things are set up to be quantity based, and then the whole purpose of, I guess, taking the dual is that you get prices. It becomes dependent on price rather than quantity, because you like looking at the Lagrange multipliers, or shadow prices or something. But can I sort of introduce something that's going to be a little bit weird?
Sure.
Okay. So I'm going to take okay, I'm not writing. I'm going to take two vectors. That's not black, that is green. Okay, this time I'm going to take two vectors in Rn plus, and let's see, I'm going to designate these with hats. because these are going to be fixed.
Mhm.
Okay, do you know what I mean when I write this?
Is that an R? Is that real?
Yep.
Your handwriting is sometimes better than other times.
So the non-negative real space and dimensional.
Yep.
Yeah.
Usually my handwriting is better when I write more, and I haven't been writing very much. So about 2 weeks into the semester, it gets to be really good. Yeah, you're never going to believe this is going to be my quantity and my price. So basically, it's how many things I buy and what I pay for them, right?
Mm-hmm.
So Q hat dot P, that's the total value. Right?
Yes.
How much money I throw into the thing. So the way that I'm thinking about this is that I wanted to find, okay, this is going to be a real abusive notation. You guys may not care, but I certainly do. I'm going to define this sum, and it's going to look familiar. UI times PI. I'll put little hats on them so I know where they come from. Raised to the sigma, raised to the 1 over sigma. So that should look familiar. I don't know why I put parentheses and absolute values. So they're absolute values, not really needed because everything is positive.
Mm-hmm.
But here's what I want to do. I'm going to do something a little bit weird. Like, here's my motivation here. This kind of looks like a cost function. Cost function in quotes. It's not quite. I'll talk about why it's wrong and how I can fix it. But to me, that kind of looks like a cost function. So what I'm going to do is I am going to change this, right? Because in the actual economy, we don't know Q, we don't know P. What we really know, so we know, I'll call it Q ref, maybe put a little hat on it. And this is just going to be the vector of Qi times Pi from 1 to n. It's just the quantity of each thing I buy, right? This is the number that's reported in the IO table. It's total value. So far, I'm not lying too horribly, right?
And so you're just going to make your P's 1?
Yeah.
Yeah.
Yeah. So then we change. So we actually consider Q hat ref, comma 1. And those two things would be the same. So this is very nice because it's very easy to test calibration. Like, easy to test calibration. Because like you'll be considering a profit function, you'll have multiple of these cost functions, right? One for revenue, one for cost. And if you just plug in prices equals 1 and things balance out, which is kind of nice. And in a sense, I could stop right here, and this is kind of the explanation of how MPSGE, how you like type numbers in. Excuse me. Because when you're doing like an input, right, you give it a price, P1, and you give it a quantity. And what you'd be giving it, I'll give it PI. You'd be giving it Q ref I, just taking out the ith coordinate. So in MPSGE, that's really what you're giving it. You're not giving it Q, you're giving it Q ref, because you're sort of scaling things back. And then what I really want to do is I want to replace, let me actually write, replace Q ref with Q ref over the length of Q ref. It's getting low, so I'll move up to here, so it is still kind of visible. Because then what I can calculate is then Q ref, comma 1 we could rethink about this as the length of QRef times QRef over the length of QRef. How about 1? It's clearly going to be homogeneous of degree 1 because the sigma and the sigma is going to cancel out, and that's constant. So I can do that pretty easily. And this, I'm going to put it in quotes again. This is essentially our unit cost. It's not quite. I should stop and say, do you know why I say it's not quite our unit cost function? Well, other than this having to be a general vector P, right? Because we put our prices in there.
Can you just say what is the length of QRef? What does that mean, actually?
Oh, this thing right here? Like, it is the square root of QRef dot QRef. It's just the length. So like Pythagorean theorem, square root of a squared plus b squared plus c squared.
Mm-hmm.
That's it. So hold on. The reason this isn't exactly the unit cost function is because this Q is under the sigma. And really what MPSGE does is it does this theta price I guess it's 1 minus sigma, but that doesn't really matter. Right, because I'm just sort of doing it in generality and it could change sigma later. It looks more like this, where this, I guess it's sigma I. Sigma I is exactly that.
You mean it's theta, right?
That is a theta. Thank you. Sorry.
So I'm just like,
after a certain point, everything becomes a sigma.
well, it depends how you draw it. Yeah.
Well, but yeah, and the Q, because of the functional form, the Q actually multiplies out. So it's multiplied by the actual reference quantity, such that the total cost would be that multiplied by the quantity, such that cost just applies to per unit of production.
Yep.
Well, it must multiply by the level of production, by the Q.
By the share of production, yeah. Right. Because that's kind of what theta I represents. I almost said sigma again.
Yeah. It's a cost share. It's a cost share. But that whole function is when you multiply it by the level of output, will give you the total output cost.
Yeah, that output is QRef, is that guy right there. Just sort of like that. That's just what it is, right? And yeah, let me look at here. Yeah, I ran into this little headache just a little bit ago, but I think I don't actually think this is a big problem because right now this one is really QRef times, come on, the sum, those QRefs are on the inside divided by blah times PI. Yeah, the problem is that here the QIs are inside the sigma, here they're outside the sigma. But I think I can do away with that with just like a monotonic transformation, like I do something here. That's not going to affect the max or min.
Mm-hmm.
Which is, I don't think that's actually going to be an issue. It's annoying for my analogy, for sure. And this is exactly what you get in MPSGE. Like this is how you define the cost function, or unit cost function anyway. This is exactly as defined in MPSGE. You have to be a little bit careful because these prices can really be like some price prime times like some taxes maybe divided by a reference price. Those prices could be adjusted so that they actually start at 1, like they're offsetting some tax accountability. That RP is reference price. But that's just a linear transformation. That's not a big deal at all. It's not going to affect what's going on. It's just recalibrating your things. But yeah, that is like, that's the core of MPSG. From here, everything is pretty straightforward. Because if this is your cost function, so I'll call this C sub sigma of P, right? The compensated demands are just the partial derivatives of these guys with respect to PI. And that gives you the market clearing conditions. That's Hotelling's lemma. I guess this isn't cost.
You're talking about factor demand. So this would be the factor demand for a unit input for inputs into production. On the consumer side, you have the utility or the cost expenditure minimization problem, which then has its own expenditure function, which you then take the derivative of to get the compensated Hicksian consumer demand. And see, I think that's the part that most people who will have either learned CGE modeling from what are those folks in Quebec? So there's I'm trying to remember the name of the PEP, the PEP group up in the University of Montreal, and then there's the Robinson, Lofgren folks, or the folks who do like or the folks in Europe. They will not come to CG modeling necessarily through this, and so I think that making that equivalence earlier on that leads up to this, I think would be I think most helpful for people that are coming from that side to the MPSG approach. And it's something that most PhD students in their econ programs will have covered in their first year, but it's never put in terms of an applied problem like this, and so most people will learn it and forget about it. But if you go back and remind them that actually this is how everything was derived from, the equivalent of the utility maximization, expenditure minimization, or or profit maximization versus cost minimization for the producer, leads to these functions that have the direct that are basically the building blocks of the MPSG approach. I think that's where it will be most helpful to draw that distinction. And
yeah,
I was looking for a little toy example that maybe we could use as a way of, if you take it from the classic formulation into the dual formulation, and then actually show how the unit cost functions and expenditure functions are derived. I think that would be extremely helpful for people.
Yeah, I've been looking. So I've asked Tom many, many times for something like this, and I've never gotten like a good, because these are typically solved as an optimization problem, right? Like you're trying to maximize maximize something according to constraints.
It could be,
or it could just out of there.
It could be written out in terms of the first order conditions, but yes, it's built upon the the implicit maximization of. Sorry, I was actually looking at something last night, and anyway. I will after this call. Because I had a nice little write up that was used, I think, by someone from the World Bank for training, and it's built from a very simple example. It starts with the SAM. That's the other thing that the way Tom and Jim formulate the sort of that is a little different from the classical SAM approach, and so showing that all of those things have equivalence is just packaged a little bit differently. I think will be very helpful for people who are coming from because now there are a couple of textbooks on CGE modeling, but they're all built on a different approach to thinking about the problem. And so for those people who might be learning it that way, having them sort of reorienting them a little bit in terms of how it's formulated here will be very helpful. And I think they'll find it, that's just it'll help the market, increase the market share of MPSG. I think if we do that.
Yeah, I don't think Tom ever gave attention to people actually using MPSGE.
Yeah. Well, it's like, it's like the Windows versus Mac. I mean, when I started using computers in 1991, I hesitate to say that. Literally, it was so clear which was the better product. I mean, if you looked at your Apple Macintosh and you looked at what the folks pre-Windows were using, it's clear what was a better product. And it's but the fact that the Windows guys made a bigger effort to get their product into the hands of more people is what prevailed.
Yeah.
So I think he has yes, it's a fantastic product, but we have to do the work to get it into the hands of more customers.
Yeah. And that's part of it's because people don't understand how to use it.
Yeah.
It's very powerful. I don't think it's restrictive as people think. But it's just.
Yeah, they just need a little help, a little conceptual help. I think will go a long way to just help people make that transition.
There, I'll show you. Does this? Here, I'll ask you if this makes any sense. Minus A transpose P is less, or no, I think it's greater than 0. Have you ever seen something like that before?
In optimization, yeah, that looks like one of the dual constraints. But yeah, that's
yeah, this is what Tom is talking about with MPSGE.
Yeah.
This is how he always described it to me, and I don't think that's helpful.
Yeah. That wouldn't be obvious to someone who hadn't you have to start with the primal of the original problem and then derive how you get to this one.
Here, I can show you. I found this right up. Come on. Where's my mouse? There it is. Found this right up. I'm curious if you've seen this. This is a write-up by Tom.
Mm-hmm.
Okay. Sorry, my mouse likes to freak out. Calibrated shares forms, CES functions, useful hints and formulae.
Yeah.
He starts with utility function, derives the demands, and then immediately has a typo when he gets to this.
Yeah.
So this is something that I have to. I'm hesitant to go through this because I've done this with Tom's work before. And the math is usually right, but there's just a ton of typos.
Yeah.
Yeah, but the other problem with this is that it doesn't walk through an example.
Yeah. Yeah.
And I just really want it to do that.
Yeah. Yeah. I'm happy. I'm happy to. I'm going to look for that problem, and it'll be nice in the context of an actual numerical problem. I mean, you can start from the derivation of all the functions, but to apply it to a relatively simple problem, just one country, it could be open economy, doesn't matter. But I think just showing it in its sort of the way most of the world would do it in terms of its primal form, and then deriving its equivalent in terms of compensated demand functions for consumers and sort of the cost minimization problem on the producer side, and showing that it leads to you get the same solution, and then then you can just proceed. It'll just help people make that bridge, and and even and just showing that it's incredibly messy once you do it. If you do it once, you see how incredibly messy it is to make that transition, and then that's where the power of MPSG comes in terms of you don't have to derive these anymore and make typos.
I really want the tagline of MPSG is leave the math to the mathematicians, because it's not math, or it's not economics. It's math. I find it interesting, therefore it must be math, right? But I've always wanted that. I wanted an example where it starts with the traditional NLP formulation and then shoots over to MPSGE.
Yeah. Yeah. If in the course of this call I'm able to actually put my hands on the example I was thinking of, I will send it to you. Otherwise, I'll look for it offline and send it to you later. But I think it would be I think it's from a USAID training But it starts from, yeah, I think it would be really nice to have something like that, because, as I said, people don't teach this much anymore in the U.S., but those people who will have learned it are going to learn it a different way, and it's just going to be hard for them to make that transition. But I think that once they realize what it is, and how easy it is to apply, I think they'll use it.
Yeah, I realized while you guys were talking, Eli asked what this meant. I realized I was wrong. It's not Euclidean. It's just the one norm. You just multiply them up and add them together.
Yeah.
So yeah. Totally misspoke. Sorry, Eli. On me.
I still don't understand, honestly, but either way.
But yeah, I'll make this better. Don't worry. Rough work. I'll make it actually make sense when I write it up.
Yeah.
But I think there's a lot of very interesting mathematics here that may not be apparent to the economists. Like, for example, because you start with a problem and then you immediately put it to the dual, right? Like for MPS, like what we're doing here. And oh, I can show you here. Like that's what Tom does, right? He starts with phi, he ends up with sigma. And then there's this condition that phi is sigma minus 1 over sigma.
Mm-hmm.
I'm curious if you guys know the importance of that, why phi is defined that way.
Right, but I always just thought it was just for slightly less, just for the symbolism.
Yeah, because in terms of what's the actual so the elasticity you'd go and want to measure with data would enter in a very, very complicated way if you tried to actually put the symbol for the elasticity itself into your formulation. So that transformation helps just to keep things a bit cleaner when you're actually writing it out.
You're saying you think there's something even more significant?
Yeah. So it's much more significant, right? Because you start with a power of rho, and that becomes a power of, I guess it's px. I should be a little bit better. 1 minus sigma, right? Like elasticity of substitution, when you put it in your equation, it's 1 minus.
Mm-hmm.
So I haven't horribly lost everybody yet, right? Okay, I've lost my mouse, apparently. But 1 over rho plus 1 over 1 minus sigma, oh dear, is equal to 1. Have you seen that before? I've asked Ed about this, and he hadn't seen that yet.
I could, yeah, I haven't worked through that, but I would take your word for it. I mean, looking at your
the math works, yeah.
I can see how that could work.
Yeah, this is fascinating to me because May, have you seen this?
No.
Okay. So here's why I think there's math here that I want to understand. Have you guys ever used LP, the LP space, LP norm? You have, you may not realize it. This is the set of all functions such that the integral of f to the p d whatever is finite.
A lot of economists don't get taught measure theory. Maybe in some econ departments, but at least maybe at Stanford. But I think many economists do not do that first year course in measure theory.
It's not full measure theory. It does like measure theory.
Yeah.
But this is more functional analysis stuff. It's just basic analysis. Well, not basic, functional. But so when I went to grad school, I initially went to grad school to do functional analysis. I went to Texas A&M, which is like the best for functional analysis.
Mm-hmm.
I ended up doing combinatorics, which is a little bit different. But this space, there's also a space. Okay, you can obviously have another space, LQ. And LQ is equal to LP dual if 1 over P plus 1 over q is equal to 1. This stands for dual. So when you talk about the primal and the dual,
Yeah.
that's why that power pops out, because you're going into the dual space.
And I think the way that economists use dual, sometimes it differs.
This is also what I want to know.
There's the way my professor uses, there's the Lagrangian dual. So there's a dual that you can. So when you have your Lagrangian function, if you rearrange the terms, because the maximization point is the saddle point. It's where the minimization of the dual and the primal basically meet at that saddle point. And so any problem for which you can write out a Lagrangian, you can rearrange the terms of it and come up with this dual, such that the objective function will be exactly the same value at the optimum. But that's not what the expenditure minimization and utility maximization problem yield you. You don't get, it's more like an inverse problem where you say, I'm going to minimize my consumption expenditure subject to the constraint that I at least have to get the same utility that I would have if I had done the equivalent profit maximization problem. And you only get the same answer if you set that lower bound utility to the maximum of the other problem. So you have to kind of constrain it. So it's dual, and it's not dual strictly in the way that I think mathematicians would think of it.
I think it is. I think at its core it kind of is. Like, it's more restrained a little bit.
Yeah, but you won't. But the minimum of the expenditure minimization problem is not numerically equal to the maximum of the utility. Those are two different. They're in different units. One's in expenditure units, one's in utility units, and so it's not as clean, right, as you would normally think about a problem and its primal and its dual.
Yeah. Yeah, it's an example I need to work through. I have, hold on, for the book. I have this book.
Oh yeah.
Ovarian, yeah.
Yeah, very. I've worked through this,
Yes.
and Tom was like, if you work through this and understand all of it, you'll understand what you're doing. So I did that, and I still didn't fully comprehend the connection. Yeah, there's something there.
Yeah. Variant's book is very good, but it does, again, it does, there's some details that aren't in there that sometimes I use that as a first year grad, and I had to go to other sources sometimes because it's very concise. And everything in there is correct, but it will leave out certain, it won't necessarily give you, especially if you're coming from the space that most mathematicians would come from, it may leave out a couple things, but
yeah, I think the hardest thing for me to get used to is having stuff that is actually useful.
Yeah.
It's the biggest change for me academically. Let's see here. Okay.
But yeah, I will look for that
Yeah.
example, and maybe we can work through the math of it and then see if in terms of getting it to solve in both, even algebraically, in both its primal and dual forms, and then taking the dual form of it into the MPSG and showing how it's equivalent to everything and how it's that's set up in the MPSGE. I think that would be a huge contribution that I just haven't seen from Mark and Jim and Tom have done incredible work in terms of providing course materials that lead up to that, but there's a little bit of a leap that would be helpful to get people over.
Yeah.
I think what I'd be really interested in is the fifth grader explanation.
The what? Oh, fifth grader?
Yeah, where it's like
explain it like I'm 5.
Yeah, it's not
Eli's.
not as rigorously mathematically, but yeah.
Yeah, so what I would really like, that looks too much like Eli's. I'm sorry, I have to What I would really like is exactly that. A couple
Like
different levels
both,
of
right? You need
explanation,
the
right?
method. Yeah.
Like general overview.
Yeah.
Yeah. General overview with a mathematically correct example.
Mhm.
And then, sorry, there's a plane flying over my house. Let's see if I can see it. I think it's an F-35. They're very loud. Really simple example, simple explanation, simple example, linking things up, mathematically rigorous.
Yeah.
Because I think it's important to have the mathematical rigor. As
100%. Yeah, I
obviously
think
I would.
that sounds good. But I think starting with the intuition on that level is really good.
Yeah. So let me ask you more questions. I think I've already gotten Eli over this hump. Do you have any care if I never talk about a revenue function and just talk about a cost function?
I think it's better to talk about the cost function.
Yeah.
I mean,
well,
are
yeah.
you talking about like the profit? Because you can talk about a profit function, right? In
Yeah,
terms
profit.
of on the producer side. Is that what
It would be plus C of S, right? If T is your elasticity of transformation, it's just a negative elasticity, essentially. That's how this becomes plus. So that becomes plus. Because you're just popping a negative elasticity in there.
Yeah, I think the term revenue function might be a bit confusing for folks because they will not have heard of it in that way.
Good.
So I would just refer to the cost function. They will have heard of a profit function, but not necessarily a revenue function in the way that you're. Yeah.
Would they heard of something like, or would they be uncomfortable with something like this, where I just specify that it's a negative elasticity?
If you can derive it to show that, yeah.
Okay.
Yeah.
I mean, it's the same functional form. Right? If I defined C sigma to be sum of this to the 1 minus sigma raised to the 1 over 1 minus sigma, you pop a negative in there and it's the same thing. It reduces a lot of work because then I don't have to take two derivatives. Other than Cobb-Douglas, which is when sigma equals 1, that's a different case. That's fine. Yeah, I find it there's a lot of very interesting little math things that are similar to other math things that I think is very interesting.
I mean, you could call it a transformed cost function or something, but I would avoid the word revenue just because it's going to that might cause more confusion then.
Yeah, that's fine.
I would have to say I personally do like it just on the intuition, but if you're saying that it's sort of counter to what economics PhDs would have in mind, if you say so. To me, it's sort of intuitive, right? Like basically what are you trying to do? You're trying to figure out the point at which they equal 0, you know?
So the point at which,
well,
yeah, you have minus profit equals 0. I guess you have profit equals 0, but the minus is more helpful. Orientation on solver. So I've been reading a couple papers, and a lot of them are using like integrals, which is totally cool. Is there a way to reformulate these problems in terms of integral problems?
Were you taking the integral of what? Of the
they were doing it of like the cost function. There were a lot of words, but I definitely saw integrals.
But I'm trying to think in terms of the discrete versus a continuous, because they were talking about like discrete time versus continuous time. But so the reasons to have an integral is because what are you are you dividing something into smaller and smaller units such that you can?
Sure, maybe.
I think the key thing here is that Mitch, when you write out the cost, which is marginal cost.
Yep.
So the integral is actually
You're
integral.
adding them up.
Yeah.
Yeah. Does this, so basically when I look at this,
Yeah.
right, I look at this power and that is 1 minus sigma, 1 over 1 minus sigma, right? This is
Yeah.
x, 1 over x. So this to me looks like it has the exact same form as a cost function, except it's an integral instead of a summation.
Mhm.
Right? Yeah, I have to read this more in, there's a lot of words here that I
This is
Does
more
that just
like
mean-
on the this is more on the quantity side.
Yeah, this
Okay.
is a CT function, right? Where you're
Yeah.
taking, yeah.
interesting. CET, isn't that same as CES? Constant elasticity of transformation?
Yeah, this is a CES function. So if the rho equals to sigma over is that or just
Yeah.
the opposite?
Yeah, this is
it's
just
system
rho.
like this. Yeah. CET is that you have you change you only flip the sign of the sigma.
Yeah.
Yeah, that's exactly what I was doing here with the minus.
Oh, I see.
Yeah, that's exactly what I was doing. You just flip the sign of the elasticity and then it flips up there.
Although, yeah, they're used in yeah. Okay, I see what you're trying. But
Yeah, I don't see a lot of difference between CET and CES. They're the exact same thing.
but one would be used to describe how inputs substitute for each other in a production technology, and the other one would be in terms of how let's say land can be
Let me rephrase this. Economically, I believe that they have different interpretations.
yeah.
Mathematically, they're the same thing.
Yeah, they have very parallel properties, yes.
Okay.
Yeah, but they signify different things in the.
Can I tell you what I view it as? Because like x to the minus n dx. Do you know that integral? Right, it's
yeah, sure, I've seen it at some point.
minus n plus 1, 1 over minus n plus 1, right? I guess plus c. Is that right?
Mm-hmm.
No, because it is a natural log of x if n equals 1. Hold on, I'm gonna get yelled at a bit. I assume you guys see the analogy here, right? This is Cobb-Douglas. That's the Cobb-Douglas case. When n equals 1, it's different. There's like some branch cut or something or whatever it is. That's always the analogy that I've drawn in my head. Like the Cobb-Douglas is the natural log case of this, which it is. It literally is.
But can you draw another parallel to the CES function from this integral?
This guy?
There's no like direct.
No, well, kind of. It's an integral instead of a summation, which is fine. And this is trapped under the power, which is the problem that I had earlier.
Right.
Yeah, this paper is
Integral
like
instead-
60 pages long. Oh my god.
Integral instead of the summation just means it's like
Continuous.
analytically, yeah, and then you can only solve it analytically and
Yeah, because the other thing that I'm thinking about, so I double majored math and physics, so I know a lot of both. And I don't know how much you know about physics, but there's Newtonian mechanics, F equals ma. And you can derive most things from F equals ma. But that's a differential problem. And then you also have Lagrangian mechanics, which are an integral problem. And I mean, obviously Lagrange there is going to be important because Lagrangian and there's a connection. Yeah. And the reason that I'm curious about integrals is because the Lagrangian in physics is much easier to solve. Much, much easier to solve. And there's like, there's conservations here, right? Like there's conservation of money, zero profit. There's conservation of items, market clearance, conservation of income, income balance. There's a lot of parallels that I'm interested in that I can't, it's hard to Google.
Yeah.
Because the other thing with MPSGE is that it won't change GDP. I believe GDP is fixed at MPSGE. So if you put a shock in, I think it'll give you the same GDP.
I think it depends on the closure, right? Like any CG model.
I'll have to check. But in the test that I've done, it's essentially preserved. But I have to check on that as well.
Yeah, I think in common closures or whatever, that's probably true. But I don't think it's 1-to-1.
My
Yeah, go for it.
experience, if you put a shock, depending on where you put it, so we get into, because a standard CGE will involve intersectoral linkages. So we get into a production network. For example, we get an output shock, make one sector more expensive, and they supply less, and their cost will pass on to whatever downstream industries. And then downstream industry will respond, and including final demand, they will respond with the demand changes. So these demand changes will flow upwards to the upstream industries. So all of these are actually, I think they form a line of literature as termed as the network, production network. And so all of these are actually, if we include all of the changes in the CG, including final demands, and so they have some of the impact transmission or propagation mechanisms. So that would affect GDP, and especially there's another form, like if a model that that features the labor leisure choices. So demand being affected, and then it's going to affect the decision for labor supply, and that would affect the endowment. So like the factory endowments, and if we get into the dynamics, and the capital accumulation will be affected.
In dynamics, if you go over time, GDP should be able to change. Because you are increasing something sort of exogenously each year. You're increasing like the interest rate or something.
Right.
So you expect things to increase.
Yeah.
But I think that the endowment and trade is where you would see potential changes, right? If you didn't have a fixed endowment in a model, and if you had some trade element that could change, that's where GDP could change, even in a static model.
If we have the regional trade in there, then there's a shifting comparative advantages, and that would change.
Yes, because typically, I think we consider trade to be exogenous, so we fix the trade. So if you're not sending more money outside the country, right?
Yeah, I'm not, whatever. I sort of have vague ideas of this stuff, but as I understand it,
Yeah.
Commonly as a closure, and that's what I was sort of saying. Like commonly, that would be one way to, common way to sort of do a closure on a model. But I don't think it's necessarily. That's what I'm sort of saying. There are other ways to do it that would mean that you could shift, say, the trade, or even, as May said, like I think the endowment being not fixed and basically dependent on something like a labor leisure choice, in which case there could be more or less labor in the economy, which would change GDP, right?
But at the same time, if you change the labor endowment, you've changed the GDP in sort of the initial thing.
So that endogenously, you're changing it endogenously based on
but then the GDP
relative
would
value
start.
of the leisure.
The GDP would change because all of the like whatever you put in shock on input or output is an efficiency change. So it means that finally is whether your value whatever the value added efficiency is going to go up or go down depending on the sign of the change, the shock.
How about if you modify a tax rate? Like if you do something very simple.
Yeah, second best.
Yeah, I'll check it out.
So if you modify a tax rate, but your endowments are fixed and trade is fixed.
Yep.
We'll redistribute some income, but
yeah, because it would affect income, but that would also drive down other people would buy less or more depending on the tax, I guess.
I think there's an efficiency law. I don't know, actually. There's a welfare efficiency loss, but like in terms of GDP, I don't think if you have fixed endowments and fixed trade, I don't think GDP can change.
Yeah, there's a lot of levers. And it's hard to determine which lever is doing what. Yeah, I think this helps me. I'll try to write something up that's coherent. See, while having a simple example would be incredible if you could send that.
Yeah, I'm gonna look for it right up.
It can be a PDF, and I'll spend my time recreating it.
Okay. Yeah, I just need to find how I labeled it in my files, but I have the hard copy here. Worst comes to worst, I can scan it, but no, I'll find it though.
They have apps. I guess this is my teaching background. What kind of phone do you have? iPhone, Android?
I have an Android.
So if you just open the camera and point it at a piece of paper, it'll scan it, and then you can add more to the scan.
Yeah, no, I should be able to find the feed. That'll be the last resort. But yeah, I'll because I also can scan it on my machine here. But
no, the camera scan is super high quality.
Oh, is it? Okay.
Hold on, let me find something here. I'll show you because it's actually it kind of blows me away. This is how I had students submit exams before and after, or during and after COVID. They would scan them and then submit them on Canvas.
Back in the day when I did calculus, I took photos with a digital camera of my. I was traveling in Queensland, doing it all on paper and taking photos. But this like auto scan.
Yeah, all of these are PDFs. So Tom wrote this on a piece of paper, and I literally just pointed my camera at it. And it said, hey, scan as PDF and add more pages.
Oh, actually, so in Apple, it will be in Notes.
Apple, probably.
Yeah, Notes, that's easy to just scan something and then it can scan it into very
a multi-page PDF.
Yeah, multi-page PDF.
Yeah, that's what I do for everything though. Oh, here. Yeah, there's a minus ATP, right?
Yeah.
It's not right. Did Tom ever tell you that this isn't technically right? Because this is the no tax version.
I see.
You have to adjust it if you put taxes in there. Yeah, this is my early work to recreate MPSGE before I realized none of it was actually necessary. And it's easier to just construct the equations explicitly. But this is the whiteboard in my office, and it just scans it as a PDF. It detects it and just... Very nice.
Okay, yeah. But I'll do that. I'll look for that and then I'll send it to you.
Yeah, totally cool.
All right.
Yeah. Stop sharing. Sorry, I can't change my desktop background. My dog passed in April, but I just can't bring myself to change it. It's the same with the TV. on our TV, we just have it display pictures of our dog when it's not casting anything.
Yeah.
And that's what it's been for like 10 years. And now it's slowly running out of new pictures.
Yeah.
It's been enough time.
All right, folks. Good to see you all.
Yeah,
Yeah,
thanks for
too.
coming. Thanks for answering my questions.
Sure,
Thanks
no
for
problem.
humoring me.
Yeah.
Thank you.
All right.
Yeah.
Bye, everyone.
I don't know, I was gonna just log off. I don't really have anything. Oh, we're still recording.